In this video, we are going to discuss the following things. How we use the WIT transformer in our expression tracking and its drawbacks. What is face mesh? How face mesh resolves the issues and drawbacks of WIT transformer. Need for a child dataset and how we plan to create it. What kind of model we will be building for expression tracking. As I have mentioned before, in our previous project, expression tracking for dyslexic kids, we have used Vision Transformer, which was built on dataset FER 2013. And main aim of this model is to recognize the facial expression of the given image. So we do capture images of the dyslexic children and give to this model. This model will analyze the image and give the expression as an output. It may be happy, sad, angry, or anything. This model has both advantages and disadvantages. Let's look at them. Advantages of VIT. Powerful feature extraction. It captures relationship between the facial regions using self-attention mechanism. And other advantages are high accuracy, no manual feature engineering required, and scalability. But it also has some disadvantages, which are slow processing, high computational cost, data set dependency, and lack of real-time adaptability. As we discussed earlier, the vision transformer for expression tracker has some disadvantages. So, to overcome these disadvantages and perform expression tracking during the gameplay for dyslexic children, one such solution is face mesh. Before understanding face mesh, let us see what is face mesh. A face mesh is a real-time facial landmark detection model developed by Google's MediaPipe. It detects 468 key facial points from a 2D image or a video without requiring depth sensors. Face mesh is a lightweight, fast, and efficient, making it ideal for expression tracking, AR applications, and facial emotion analysis on mobile app and web platforms. Now, as we understood what is face mesh is, let's see how face mesh resolves the issues and drawbacks of vision transformer. The first one is real-time processing. Face mesh runs instantly on mobile and web, unlike WIT, which is slow and computationally heavy. Next is low computational cost. Works efficiently on regular devices without requiring any GPUs or high-end hardware. Next is no large dataset required. Face mesh extracts facial landmarks directly, while WIT depends on extensive labeled data. Better for micro expressions. Tracks 468 facial points, captures minute expressions that WIT struggles with. Next is energy efficient. Runs smoothly even on low power devices, unlike WIT, which consumes significant energy. Till we have seen the disadvantages of WIT transformer and how those disadvantages are overcome by the face mesh. Now it is our task to build a model which is trained on face mesh data and does expression tracking. As we know, our project is expression tracking for dyslexic kids. That means we have to track the expressions of the kids. So here comes the question, why do we need a child-specific dataset? Helping dyslexic children enhances learning by analyzing their expressions during the gameplay. Unique child expressions ensures accurate emotion detection as kids express differently than adults. Better AI training, personalized learning, fair and ethical AI. So we can say that if we train a model which is completely built on child-specific dataset, we might get good results in their expression tracking. So as we now decided to use a child-specific dataset for the training of the model, let's see how to plan to create that model. The first step is data collection. We have to collect the data of the child images. Then face mesh processing, then pre-processing the dataset storage, model training and testing, optimization and bias correction, and the last one is deployment and continuous improvement. Now let's see the plan to create a model on child-specific dataset in detail. The first thing is data collection. We have to capture facial images or videos of children during gameplay, ensure diverse expressions like happy, sad, confused, etc. Then face mesh processing. Use face mesh to extract 468 facial landmarks per frame, convert the detected landmarks into numerical arrays. Then comes the pre-processing. Normalize the landmarks coordinates for consistency. Filter out noise or incomplete frames. Annotate data with corresponding emotions. Just taking the face mesh data isn't enough. We need to store them. So, dataset storage. Save the processed landmarks arrays in CSV format. Categorize based on expression and engagement levels. And here comes the most crucial part, model training and testing. Train the emotion detection models using the dataset. Validate accuracy by comparing with labeled expressions and optimization. Bias correction. Fine-tune dataset to avoid biases, emotion recognition. Ensure inclusivity across diverse child demographics. Building the model isn't our task. We need to replace the WIT transformer that we are previously using in our expression tracking with the face mesh. Implement the dataset in expression tracker system. Collect real-time feedback for further improvements. So, as we have discussed the plan to create the model, here comes the question, what kind of model we will build for expression tracking? We do have a lot of options to create a model for expression tracking using FaceMesh, and they are SVM, Support Vector Machine, Random Forest, CNN, Convolution Neural Network, and Transformers, along with LSTM plus CNN hybrid. We have different models and they have their own advantages and challenges. Let's look at them one by one. SVM, Support Vector Machine. We can use this model if we have limited data and extracted numerical features from FaceMesh. We can use random forest if we want a fast interpretable model for structured landmark features. If working with raw images or FaceMesh heat maps, we can go with convolution neural networks. And if we are working with sequential facial expressions over time, we can use transformer. We can use LSTM plus CNN hybrid if we are tracking facial recognition expressions over the time. Every model has its own advantages and challenges, but in our case, for our project, as we have limited data set of child images, we can choose support vector machine, which works well with small data set and simple implementation. But the challenge is it struggles with large scale or high dimensional data. If somehow we increase our data set and then we can go to transformers, which is good for complex temporal patterns, handles the long range dependencies, but its challenges high computation cost and requires a large data set. To conclude this, I would like to say that FaceMesh is a very good replace for Vision Transformer because it is lightweight and we can build a FaceMesh model with small dataset also. Thank you.